Hello, everyone. My name is Angelo Prila.
And my name is Nayfa Isbeih.
My name is Miles Henninger. Our team name is Team Soul, and we chose the vessel tracking system as our project. So here's the vessel tracking system app itself. We added a lot of features, the first of which being the big data table at the bottom of the app, which basically shows all of the parameters that are used to display the ships on the coordinate map in the top right. We have a speed alarm, which will alert you if a ship is going faster than a certain threshold, which can be set here. There are codes that you can type in to display a specific ship. There's a filter for max speed, which will hide speed values that are over whatever you set. So we're just going to do 8 as an example, and that removes all of the values above 8, as well as sections where you can delete columns and delete rows if you don't want to see them. So if I click begin ship tracking, we can see that the ships start moving around the map in accordance with the latitude and longitude values on the table. If you saw at the beginning, the speed alarm turned red. That means a ship was going over the threshold of 20. So as you see, that's what it's set to. So the speed alarm is turned on.
First, let's talk about the core component of our project. What I was in charge of here was to import the map, create the graph, and then as well import like our database into the MATLAB App Designer app. So firstly, I made a script file in MATLAB for all the preset coordinates and other statistics. And then I made them all as arrays first, and then I used the table command to concatenate them all. And then finally, I used the write table command in order to convert it into a CSV file, which would be much easier to import into App Designer. And then speaking of which, so first I created a variable to read the data from the database, and then use the UI table properties in order to save it. And then the other part I also did was finding a map and then finding a way to import that into the MATLAB App Designer. So for the core component, I decided to import a map of the Eastern Mediterranean Sea. And in order to do that, I first downloaded mediterranean.gif and then moved it to the same folder as the App Designer file, so that when I use the imread command, it would just display the image of the Mediterranean Sea. And then I'd use the image function here in order to display the map of the Mediterranean Sea, and also to flip it so that it's not upside down.
For my portion of this project, I was tasked with plotting the ships onto the coordinate map, as well as implementing a speed alarm. In order to do this, I first I set variables which access the data table and set the range of latitude and longitude functions that each ship uses, as well as the speed values for each ship, which we'll get to later. And then using a for loop to plot each ship movement onto the map. So the for loop goes from 1 to 19 since we have 20 values. If it is not the first position of the ship before any of the ship's movements are plotted, the old movement will be erased, essentially just by plotting another point directly on top of the previous movement in the color of the background, so you can't see them. And then with each ship has a line of code which essentially just plots it onto the map using the latitude and longitude coordinates, and specifies the color of the marker, which is different for each ship. In terms of the speed alarm, this was very easy to implement. So first, the option to set the value of the speed alarm threshold, that's handled using a simple callback, which essentially just takes the value that the text box is set to, and then sets it to the variable, which handles the speed alarm threshold. So for the actual code for the speed alarm, that's handled with this simple if statement, which basically checks if the speed value for any ship is above the threshold, and if it is, it will change the speed alarm lamp color from red to green.
For the main components, I was responsible for the 4 reach functions, which are filter ship, filter speed, delete column, delete row. So for filter ship, you could type in a code and it'll filter the ship dependent on length. Max speed and filter ship, because they're both filter functions, you can only do one or the other. So because I did filter ship, I cannot do filter speed. We showed filter speed in the beginning. However, you can only do one or the other. Whereas delete column and delete row, they will always work regardless of what you do. And the reason that I can't do this is because let's say I try and filter speed, it'll give an error that talks about the actual row indexing. And this is because for the code view, this is all set to the app.x, which is the data table file. And the data table file is essentially already has a preset value of numbers. And because of its already preset value, since it's changing depending on the filter function, because it completely deletes those values, it doesn't work. Whereas for right here, row number and column number are for those delete column, delete row. Those are both coded exactly the same. The input value that you put ends up just setting that to 0. Same thing for column. And the only difference between column and a row is that for column name, I also had to put a function for column name, which will delete the column name and the actual column values.
Next, we're going to demonstrate the reach components of our project, which was uploading these into ThinkSpeak. And then, all right. So first, we have like all this pre-typed data because it would take a while to type them all out live. So press the upload button. And then here's the VTS display with a different map so that the viewer would have like ultimate like freedom over where the ships would go without them crashing into land. Here's the ThinkSpeak channel, which all the data would be uploaded to. And then we can display the data on the table, and it would show all the data that we just uploaded in the ThinkSpeak. And then we can begin ship tracking, which would show all the ships at the maximum report interval that was specified. And then if we wanted to implement the speed alarm, this time you press a button after you've typed in a value, and then it would turn red if any of the ships are going faster than that.
For the VTS display function, the parts that I was responsible for were the reach features once again. So for the reach features, the only ones that properly translated to ThinkSpeak was delete column, and once again, similar to before. Delete column, deletes the first column. Delete row, I'm just going to do the second one. It deletes it. And the actual code for this is exactly the same as before. Nothing changed about it. There was no need to edit it. I tried to implement the filter speed and filter function, but basically the issues that I was having was because app.x is the initial data field that we had for our original one. The change for the loop iteration, because the size was changing depending on what you put for the input data, and since there was no set feature, it wasn't able to sort them, and it kept saying that I needed to pre-allocate speed, but I wasn't able to because this is heavily dependent on what the user inputs for the speed values and what they do dependent on report interval. So the only 2 things that worked, once again to reiterate, were the delete column, delete row. However, filter speed and filter ship did not work in the VTS display part.
In order to implement the repeat intervals required for ThinkSpeak, we initially took the approach of if there's a different reporting interval for each ship, we would pause the app for that repeat interval after the ship's code had finished plotting the ship. Although we found that this resulted in sort of an inconsistent view in the actual app, with different ships having different delays between their movements, in addition to not all of the ships moving at the same time. So in order to have consistency, we simply set a variable delay time to the maximum reporting interval that was set by the user at the beginning at the app startup, and then pausing the app for that delay time after all of the ships had finished being plotted.
But otherwise, that is our project. Thank you for listening.